Hello. Good afternoon. Um, Today we're going to pick up on the definite integral one more time, and we're going to work in group again. So please spread out. Okay, so let us review what the problem on definite integration is. This was the PowerPoint, the slide that we used from last time, and what we did as our problem statement was that we started out with the polynomial, and this polynomial has the degree up to 10. Okay, so the format of this polynomial would be like a sub n multiplied by x raised to the n power, and then plus a sub n minus 1 multiplied by x raised to the n minus 1, so on and so forth. And the last term would be a sub 0. Of course, that would be multiplied by x raised to the 0th power, which of course that equals 1. Okay, so we use that format and say we are one at most polynomial of the degree up to 10. And then once you define this polynomial, we want to calculate the subinterval to estimate. Okay, we do this calculation to estimate the definite integral. It is definite because we are going to specify the origin, and well, we are going to specify the interval. Okay, because if you don't specify the interval, then it could go to infinite on both ends, and that cannot be infinite. Okay, because that now it will be infinite. So with the subinterval k that we specify, now we should be able to calculate the left endpoint, right endpoint, and midpoint estimate, as well as an error. Okay, that has been our problem statement from the beginning, as per the definite integral problem statement. Okay, and we left off. Well, I asked you to submit. I think I asked you to try to finish this one, right? With the ability to read the string and turn that into the polynomial. Didn't I? It's been a while. Okay. So were you all able to finish it? Anyway, this is the last step before I left you with the homework. Okay. So we did some temporary template of the functions we expect or anticipate to have, and then we make a function call to create the logic for our calculation. Okay, so we assume that we're gonna need a scanner object to read the polynomial string in. Okay, so we started out with the scanner object reading in from the keyboard. So we create a scanner object with the system in as the parameter to give us the capability to read from the keyboard. And once you create the scanner object, now you are ready to read it. You just display the line, okay, saying enter the polynomial. And now you might notice that I use a print line in anticipation that the polynomial text string could be long, so we start now a new line. Okay, so after you type in the polynomial string, you read it, the whole line. All right, so you read the whole line in at a polynomial. Okay, and assign that to the poly variable right here as a string. And once you have the polynomial string in the poly variable, okay, we say, oh, in this case, we are going to create a class or an object called the polynomial function. This object would be having the ability to allow you to evaluate the polynomial string, okay, at any value of x. Because the polynomial string is coming in the form of the coefficient multiplied by the variable raised to a power. Okay, you are specifying the coefficient and you are specifying the degree, the power. You haven't specified the variable, and the variable will change depending on what value you are given. Okay, so in order to get the the value on the y-axis, you need to be able to specify the x value and have it evaluated. So in that case, we are going to put the polynomial string there into the polynomial function class, so that when you call evaluate and specify the value, then you would be able to get the corresponding result of that polynomial function. Okay, and if you can create the polynomial function right here with the ability to evaluate, then you could go step by step, right? You could go step by step. See, this is the reference that we use. So let's come back to the reference. If you can create the polynomial function with the ability to evaluate any value on the line right here, that's the function value. Okay, you specified x, you should be able to get the corresponding value of y. That's the function. Okay, so if you can have that polynomial object allowing you to evaluate it, giving out the corresponding result, then you should be able to go in a piecemeal step. And then you evaluate at this step maybe, and that step, and that step, and that step. Okay? Step by step. Using one object. So that is great. But then again, in our original problem, we want more than that. In addition to wanting to estimate the definite integral using the area under the curve. Okay, and we are going to take three approaches. One is the right endpoint, the other one will be left endpoint, and the last one will be midpoint. Okay, we're gonna try to compare these three approaches. And to compare these three approaches, we use the error, which one is more accurate. And to do that, you're gonna need what? You're gonna need the actual value. Okay, otherwise you won't be able to get a grip on how good the right endpoint, left endpoint, or the midpoint estimate is. Okay, so in addition to doing the area under the curve calculation, we also want to be able to perform the simple definite integration on the polynomial itself, so that we can evaluate the actual value. Okay, and to do that, we realize that the in doing the integration, okay, let's say for example, if you have as an example right there x, we do f of x, okay, equals x squared plus 1, just like in this example. Okay, the integration of f of x with respect to x, okay, would be something like x to the third power and divided by 3 plus x. And if you want to generalize this, it would be something like, if you want to do the integration, if g of x, okay, is equals to x squared plus x plus 1. Okay, then, well, let's do ax, bx, and how about c here? Okay, let's make it more general. Then the integration of this expression g of x right here with respect to x would be something like, if we want to make it a little more general, how about we do Let's do that first. Okay, it will be what? A multiplied by what? X raised to the 2 plus 1. Okay, and then divide by 2 plus 1. Right? And then plus bx raised to the 1 plus 1 divided by one plus 1, right? And then c would be c, and then x raised to the 0 plus 1, right? Divided by 0 plus 1. That's coming from the constant. Okay? Basically, it has another constant right there. But, well, when we do the definite integral, the constant remains the same, and then it will cancel out. So you can leave it as non-existent. Okay? So for simplicity, we are going to remove the constant and assume that it is 0. All right? So you can use this formula if you have the polynomial function from the input. Then you can just follow this approach where you have the degree, you add 1 to it. And then once you add 1 to it, you move that into the coefficient and divide that existing coefficient with the incremented degree. Okay? So for all the terms in the polynomial, you can create a new polynomial corresponding to the resulting integration of the original polynomial. Okay? By picking on the degree, add 1 to it, and use that as the use that to divide the existing coefficient and make that a new coefficient, and then the new degree would be that incremented original degree for all the terms. All right? So you are now having what? The polynomial function. The first one, you have the polynomial for that function. Then you can use the same polynomial class to store this value, because after you do the integration, it also is a polynomial. So you can reuse the polynomial class, one to store that polynomial, the other one to store this polynomial. Right? You follow me so far? The original polynomial function, once you do the integration, it will be another polynomial. And because it will be another polynomial, you can use just the class polynomial function to store the value. Okay? You create the you can create the first polynomial object to store the first value. And then you can create another polynomial object to store this value. So that you can now call the evaluation method to evaluate it at different value of x. In this case, that now becomes straightforward, because now if you can do the integration like this, then you can get the actual value, right? You can get the actual value. Now, once you have the actual value, you can use that actual value against the estimated value. And now you can see the errors. Okay? So, because of that, here's what we have. Because of that, we say, okay, we started out with the polynomial function class. Use that on the polynomial string as an input. And then you pass that whole thing into the definite integral class. This definite integral class will of course take the value of this input polynomial and create a new polynomial. Store the new polynomial inside itself so that when you try to evaluate it, you get the corresponding integral value. Okay? So that first polynomial function allows you to be able to evaluate the input polynomial function at different points. And you need that because you're going to use it to calculate the area under the curve or estimate the area under the curve. Then the second one, you need that because you want to evaluate the actual value. Okay? And so, after you have both the definite integral function and the polynomial function, now you can do like getting the actual value, the left endpoint estimate, the right endpoint estimate, and the midpoint estimate. As simple as that. Right? And then that's it. So far so good? Okay. It's good, right? At least you know that the calculus that you learn could be of some use. Okay, now, what we're going to do today is that we're going to change the original problem statement a little bit. The logic behind converting the whole string right here, into the corresponding polynomial function that you can use and evaluate tend to be a little complex. And I don't want you to waste time on that. I may try that in the exam, but not here. Okay? So, we're not going to use the whole string like this to create the polynomial function, but we're going to do something easier, more convenient. Okay? So, we are going to just specify the coefficient and the degree in a pair. Okay? So, in this example, if you have this string, you are going to say something like an and then n, an and n, an minus 1, n minus 1, so on and so forth until a1, 1, a0, 0. Okay? We are going to specify a pair of coefficient and a degree instead. So that will be easy on the logic. You don't have to do the conversion of this text string into the corresponding format that you can use to evaluate the polynomial function. And that's make life a whole lot easier. Okay? Because as I mentioned, the logic behind this one is a little complex, and I don't want you to get bogged down on that today. Alright? And besides, say for example, if you have like x squared plus 1, what would be the format of the input? X squared plus 1. 1, 2, 1, 0. Right? 1, 2, 1, 0. X squared plus 1. The coefficient of x squared is 1. The degree is 2. So you say 1, 2, and then plus 1. That is the coefficient of 1 and the degree of 0. So you just specify 1, 2, 1, 0. And that would represent x squared plus 1. Okay? So we're going to do that instead. Now, we will start out as we already have started out with the template here. So, next step, I want each of the groups to focus on making this one happen, the polyfunction, okay, polynomial function. Right now, it is just an empty class. There is nothing in here. We just create a dummy. Okay? So what we want now is come in here and try to be able to do this. Or just this. Okay? Each one of these is pretty much the same. So you should be able to read in the polynomial string, but this time it will be just using the pair format of the coefficient and the degree. Okay? Read in the polynomial string and turn the polynomial string into the polynomial object. Now think about it. How should you do it? Or how could you do it? What will you need in order to do that? Don't forget that eventually you're going to need the polynomial function object here to help you evaluate the value. Okay? So you're going to have to turn the string into some format that you can evaluate. So talk among yourself. What will you need? Do you need any kind of data structure to store the value that you can evaluate? How can you do the evaluation? Okay? You can use a flipboard if you like. You can use the whiteboard, anything. Okay, say for example, you should be able to do this, and then P would represent what? Would represent the polynomial function x squared plus 1. Okay, and then you should be able to evaluate P. So create P, and then you may want something like P eval. Okay. And then this will give you the value of P. So you might need to specify the value you want to evaluate with the eval method. Okay, so it might be something like here 2, P eval 2, for example, 2.0. Then it will be equals to what? F of x, which equals, if f of x here equals x squared plus 1, then that would be f of 2, right? Which equals 2 squared plus 1, which equals 5. So p dot eval 2 should give you the value of 5 back as a result. Okay, think about how you may be able to do this, because you will need it. What kind of data structure you might need, how you can grab the value from the string that you pass in and turn that into the corresponding value that you need to do the calculation. Okay, flipboard is all around. And you can talk among yourself, okay? And you also try to do this as much as you can, because I plan to use this on Tuesday. So if you're slow and you don't get much done, then on Tuesday you're going to be slow too. Let's see if we can change the color, The green one is a little hard to see. Green. Oh, that's supposed to be x square, right? Okay. Or if you don't want to be confused, you can change that into p so that it follow the use of the variable p. It will be fine too. There's no problem with that. uh, just in case if you want the code to start off with, I posted it on Classroom on Demand. You can download it. Okay, this version of the definite integral is on Classroom on Demand already, so you can. But you can type this. That's nothing much. Okay, so let's see here's what you can or may do, right? So you know you're gonna have the input string. Okay, and that input string is in the form of the coefficient and degree pair, right? An example we saw earlier is 1, 2, 1, 0 correspond to x squared plus 1. Okay, so you are going to receive the string in as an input, but you want to be able to evaluate it. Okay, so our plan is pretty simple. The problem here is problem number 1, I think. Let's P number 1 is that you have the string, but you want to do calculation. Okay, so a simple solution for that one is you need to convert string to what? Some number. Okay, that could be int, that could be double. We'll think about it. And then when you do the calculation, okay, problem number 2 in this case, probably when you do the calculation, when doing calculation, you need to evaluate at specific x value. Okay, so one of the approaches that would be very straightforward and you might want to consider doing it is to create a 2D array. Okay, and this 2D array, here you store the coefficient and here you store the degree. And in this case, if you are going to do the 2D array, what should be the size? Should you do like for this one, on if it is for this one, what is the size that you want? 2 rows, 2 columns, right? But would you want a 2-row, 2 columns for your 2D array as a data structure in this case? Probably not, because that would only be used for the degree of, for only 2 terms. But in our case, we want to be able to accommodate up to how many terms? We should be able to accommodate up to how many terms? The maximum degree you can take is 10. So with the maximum degree 10, how many terms are possible? Anyone say 10? If the maximum degree value is 10, how many terms are possible? 11 terms. Okay, so you want up to 11 rows and in this case 2 columns still. Okay, so that meant if you are going to use a 2D array, you would want something like this, and you want it as a integer or double? Which one is safer? Double. So we want something like this. Double. Okay. And maybe a poly equals new double 11 2. Now, once you are able to create this array, the next step would be to read from the input string, right, to the poly to the array. How are you going to do that? Anyone? Any suggestion? How are you going to read from the input text string to the polynomial polyarray in this case? One of the technique is by using, anyone? Scanning. Okay, but this time you're gonna do something like scanner. Let's say I don't know, call it the in equals new scanner and then poly. And then if you do something like in dot next double, for that one, okay, the first one will return 1.0 because you are reading in a double. And you do it again, it will return what? 2.0. Okay, do it again, it return 1.0 and then 0.0. Okay, let's try it. Okay, you try it first. At many groups have the computer. Try it and see if you can get this to work. And then after a while, do the solution on this one too. Okay, so on my part, I'll try this out too. I know that I'm gonna need a scanner, so I've just import it and see. And then what else I need? I know I'm gonna need that 2D double for poly, right? I'm gonna use it as a data field. And I'll just go straight to 11 rows and 2 columns. Now, the question here is, is there any default value assigned for each cell of the 2D array here? Is there? Is there any default value assigned for each cell here? In other words, if I say something like poly 1 and 1, okay, is it an error? If we say poly 1 and 1, right, let's say right here, after I define this one, okay, is it an error right here? Is it or is it not? Oh, you return all the knowledge to 102, huh? It is not an error. No, it has a default value. 0, yes. All the data fields that you represented as the attribute will have some default value assigned to it. Okay, and in this case, since it is an array of doubles, then all the values of the cell will be 0.0 automatically. Okay, no. It is equals 0.0. Alright, now let's move on. Okay, so we prepare that as the instance variable, and now we need a constructor. Alright, so in this case, polyfunc, and we want a string in. And once you have that, it will look something like this. Scanner, let's say is f of x equals new scanner of s. Okay, and then you're gonna need that one. Why? Because you're gonna do this. yfx has next int, or you can do just has next. But has next has a little issue that it cannot detect some unwanted characters. Okay, right now we only want what? Probably an integer or double. Okay, so I'm just gonna go specific and say if fx and has next int, or fx has next double. Only these two that I will do poly I 0. Oops. That one will be coefficient, right? Equals fx dot next double, and then poly of I plus plus. I want to increment it by 1 equals fx next double. Okay, that should allow us to read in the input string and assign the values to the corresponding data structure, the 2D array. Now, once you have the 2D array, the evaluation should be easy, right? So let's try. I'm going to do the evaluation now. Okay, so evaluation public. We want to evaluate and return a double. We also want to receive a point that you want to evaluate it on. Okay, and we will start with the initial values of 0.0 maybe, and then for in I equals 0, I less than poly dot length, right? And I plus plus. Okay, you're gonna do it for all rows. Each row represents a term. Right, so you're gonna do it for all terms. And the rest should be easy. Wow, plus equals poly at I, we want to do coefficient, which is at 0. Okay, multiply by the value that you pass in, which is x, raised to the degree. Okay, I'm going to use math.pow. And it will be x raised to poly of I at 1. Okay, and oops. And then I just return value. So we're going to try this one. Let's try it. First, we are going to compile this file only. Okay, so we can make use of it. And now let's check. Okay, and then we do what? p.eval. We said at 2 it should return what? 5. Or if you want to use the example from here, that one will be what? This one, I need to write it down. It will be f of x equal x cubed plus minus 5 x squared, and then plus 5. Okay, that would be what? 1, 3, 5, minus 5, 2, 6, 1, 5, 0. Okay, and the interval is from, well, we'll do interval later. Okay, so let's try this one. And we do, we have to create a new one. That's fine. Q, G, maybe, equals new. Polyfunc, and what be 1, 3, oops, no comma, 1, 3, minus 5, 2, 6, 1, 5, and 0. Okay, and when we do p dot eval at 4 maybe, get 17. Is that 17? Anyone would like to? Yes? Oh, gee. Thank you very much. $13. G eval. Well, let's try 0. 0 may be easier. 5. Is that 5? 0? Yes. And 4 is 13? I don't know. You help me check. What about 1? You have 1 minus 5, you have minus 4, plus 6, you have plus 2, 5. It should be 7. Let's try that. Yeah, okay. So it seems like it's okay. So if you plan to change the polynomial function, you might want to do like set, create a new method called set polynomial. Let's try to do that. Okay, it should be easy. Okay, so in here I will do public void set poly and then a new string. All right. And all I have to do is let's not do it now. I'm too lazy. Okay, I need to get out this function and take it out as another method. Forget about it. You don't need it anyway right now. Okay, so you now have the polynomial function. Okay, what else do you need? You're going to need the definite integral. Okay, and the definite integral, it will does what? It will do what? It will receive the polynomial function object in and do the integration on it. The result will also be another polynomial function. Okay, so now, how are you going to do that? You have a choice, maybe, because you can have a polynomial function object as an instance variable like this in the definite integral object here, class here. Okay. Or you can just have the 2D arrays. Which one should you choose? In this case, a 2D array might be better. You don't need to do two polynomial function object. Why is that? Because once you receive the polynomial function object, you already convert from the string to array of doubles. Okay? And if you want to create another polynomial object, you're going to have to convert back the doubles to the string. And that would waste some time. So you already have the 2D arrays that you could use. You might want to keep it. Okay? So in that sense, here's what you might want to do. You might want to do the, again, double. Okay, poly equals new, because you're going to do another double, right? Oh, this time also 11 and 2. You started out with 11 terms, so you're going to end up with 11 terms after the integration. Okay? And what do you think should be the behavior of the constructor? The constructor of the definite integral class will look something like this. Public, what else? Definite integral. Okay, and it receives a polynomial function class in. Okay. So after you receive it, what should you do? Okay, this is based on this. You are creating the definite integral using the polynomial function object here. Okay, so you pass this in. After you pass it in, what should you do with it? You want to do the integration on the received polynomial function. Okay, and if you want to do that, you need to have access to what? You need to have access to the array. Am I right? Otherwise, you're going to have to work with the input text string and so on and so forth, but somehow you need to have access to the value of the polynomial function. Okay, and the best available value in this case is the 2D array. Okay, so in that case, you already pass in the polynomial function object. All you need is somehow to get inside the polynomial function object and get the 2D array. How can we do that? Well, one of the way to do it is to have the polynomial function object right here return the 2D array for you. Okay, it would be something like this. Double, okay, and get poly maybe, and just return poly. Now you have access to this 2D array. Once you have access to this 2D array, then you can probably start to do the calculation, do the integration on the 2D array. Right. So in this case, you have poly, okay, equals p dot get poly. Right. Now the get poly, the polynomial function from the object p, the 2D arrays, okay, has been assigned to this poly variable. So you have all the value associated with it. Next thing you need to do is just perform the integration on poly. And how you want to do it? Well, we did the example before, right? So for each of the term, for in I equals 0, I go until less than poly dot length I plus plus. For each of the term, the coefficient will be what? The coefficient will be what? Anyone? Will be the original coefficient. Right? Will be the original coefficient divided by the degree, which is I1, right? Plus 1. Oh, let's do 1.0. Just to remind us that we are working with a double. Agree? And then did you get everything right? Oh, two of them. Okay. And then what about the degree? Will that work? Will it work? What do you think? It should work, right? Because that's the formula that you do when you do the integration. Now we can test. Let's try to do evaluation. Okay? So we're going to do what? Public double eval. But when you do evaluation for the definite integral, you have to specify both the lower bound and upper bound. Okay, so we're gonna do the double x1 for lower bound and double x2 for upper bound. Let's specify x1 for lower bound and x2 for upper bound. Okay, and once you have that, what do you do? Well, you need two initial value double v1 or var1 maybe equals 0.0 and double var2 equals 0.0, and then for in I equals 0, I less than this, still the length of the polynomial function, which is representing the rows or the number of terms in there, and I plus plus. Now you're going to do var1 plus equals poly I and then 0 multiplied by math.pound, and you have x1 poly I and 1. Okay, similarly for this one, I'm just going to copy and paste and change that to v2 and x2. Okay. Right, and now you need to return the value. The value that you return will be return what? var2 minus var1. Okay, for definite integral. Are we okay on this one? Let's try to compile it and see if we can run a little test on it. Compile a file, and I screw up with the no, I think the parenthesis is okay. So let's see what's wrong. Illegal start of expression. So let's try one more time. Oh, okay. Where is it that I miss? It expects the semicolon at the end, which is not here. Where did I miss the semicolon? Then semicolon here. Poly I, poly plus 1 semicolon, for loop. I got it. So I need to close this one. Okay. And if we close that one, what would happen? Now, that one is additional. Okay, try again. Oops, not that one. This one. Try to compile the file. Everything is done. Okay. All right, so let's do the what? Definite integral di equals new definite unit integral, okay, and then you do new polyfunc, okay, of what? 1, 3, minus 5, 2, 6, 1, and 5, 0, 5, 0. Okay, and we do what? Di dot eval, we want to do it from 0 to 4 of di. And it is 25.333, which is it correct? I use that because the actual value is, yes. Okay, that is the actual value of the integration, the definite integration of this one. Okay, so at least now we have the actual value for the integration. Any question on this? Okay, now since we have the actual value, then the next step would be to try to get what? This estimate. The left endpoint, the right endpoint, and the midpoint estimate. Okay, so how do we do that? How do we do that? Let's try out with the, let's start out with which one? Let's do, how about that one first? Oh, not that one first. That one is the right endpoint estimate. Okay? So what do you need to do the estimate? You need to know the number of intervals. Right? You need to know the number of intervals. Once you know the number of intervals, you need to be able to evaluate the polynomial function. So somehow the definite integral class must have the knowledge of the polynomial function that it uses. Okay, that is the original polynomial function. Okay, so over here, does it have that knowledge? The answer is not now, no, because it received the initial original polynomial function, but it integrates on it and return a new polynomial function already. So it does not have that knowledge. You're going to need to somehow store the original value. In this case, since you already passed in the polynomial function here, a better, easy way to do it is to use an instance variable p, and over here, you do this dot p equals p. Now, you have access to the original polynomial function. Agree? Yes, no, maybe so? Okay. Now, with that access, let's try to do the right estimate. So you want to do what? Public double. Let me, okay, now it should be easier. Public double, and we want to do what? Right estimate. Okay, and to do right estimate, what do you need to know? You still need to know the lower bound, x1. You still need to know the upper bound, x2, right? And what else? Is that it? No. You need to know the intervals, right? You need to know the number of intervals. You need all this. Okay, so once you have that, with the number of intervals known, you can compute the step size. Okay, and the step size is basically x2, the upper bound, minus lower bound, divided by intervals. You can see it from here. Okay, it started out by calculating the step size. The upper bound here is 4, the lower bound here is 0, and 5 is the number of intervals. So basically it's 4 minus 0 divided by 5. Okay? So we do the step size here using the same approach. And now once you have the step size, you are ready to calculate the area under the curve. Okay? We need the initial value. And this is the right endpoint, which is something like this. So with the right endpoint, you will start out with the value here that is not 0, but rather at the first value of the interval. Okay, at the end of the first step. All right, to get here, what you could do is how many? Look at this. How many area under the curve you need to calculate? 1, 2, 3, 4, 5. Okay, for that 1, 2, 3, 4, 5. So if you want 5 intervals, you need to calculate all 5 of them. Okay, 1, 2, 3, 4, 5. The last one that you calculate is 4, which is the upper bound. The first one that you calculate is not 0, but rather it is the first interval value. Okay, so you won't start with 0, because when you do the calculation here, you didn't start with 0 either, but you start with 0.8. Okay, and you end with 4, which is the upper bound. So we're going to do the same. We're not going to start with 0. Okay, we're not going to start with 0. Is that left or right? Let me check. That's the right endpoint. Okay, fine. Okay, so we're not going to start with 0, and we're going to start with 1. And then it's going to go up until the upper bound. So you're going to need to include the equal sign there. Number of interval is 5, and then I plus plus. Okay, and you do while plus equals what? P dot eval. Okay, you're using the polynomial function that you had before. Okay, and then I multiply by step. Multiply by step. Okay, so the first one, the step is, don't forget you are doing the interval. So the first one, if I is 1, let's say for the example here, step is 0.8. Okay? Example here, step is 0.8. So for the right endpoint, the first one will give you 1 multiplied by 0.8, which is the evaluation of the curve at that point. And then you multiply it by the width of the step, which is 0.8. Okay? So that's why you have P dot eval I multiplied by step, multiplied by step. And then the next one will be at what? 2 multiplied by step, which is 1.6. The next one is at 1.6, right here. Okay? And then multiply by 0.8, which is the step. Alright? So it seems to be alright. And when done, you just return it. Okay. Ready to test? Before I do that, I need this. Otherwise, I have to retype the whole thing. Oh, I have that already? Fine. Okay. Now. Okay, so we're going to want to do what? We want to do the right endpoint estimate, right? So it's going to be like di dot right est, the interval between 0 to 4, and the number of interval is 5. Okay, and the value here is, ooh, it's not right. 59.07. What happened? The value here is for right endpoint 28.96, but we got 59.08. So what is wrong? Well, you probably don't know, I guess. So should we do some print out, system out.print line? Okay, and then we print out what? I probably, followed by that, followed by this. Okay, and try to see what is going on. Let's try it. Right estimate. We want 0, 4, and 5. So, why did we get all this? What is wrong? Remember, we tried with 1, we get what? 5. But we tried with no, it's not. What do you think is wrong? You see, everything is just like, is that right? You started with 4 right here, and at the time you get to that point, it blow up to 20. Anyone would like to suggest what is wrong? This is a very bad one-time error, and it's not that easy to catch though. It doesn't seem to be wrong. I mean, the formula seems to be right, but why when you actually done the calculation is wrong? Anyone would like to suggest what's gone wrong? This is a little challenge, really. And believe me, you'll hate it when it happened to you. Anyone would like to suggest what has gone wrong? We double checked the formula, it seemed to be okay. But when we did the actual calculation, the value just like too much. Not correct. Why? It's supposed to be like 20 something, but it turned out to be 59. What has happened? And we even use the p variable which we use to store the original polynomial function. Okay? So we didn't use the 2D array, we used the original polynomial function to calculate it. It seemed to be okay. So why? What happened? Anyone would like to give your opinion? A hint, the error here happened because of a term called pass-by reference. Here we go, because time is running out. The error here happened because, look at this. When you create the definite integral object, okay, you pass in the polynomial function object to it as a parameter, okay, and once you pass this in, you get poly. Remember, get poly just return the 2D array. Okay, so you are actually assign the 2D array of this polynomial function to this polynomial function. That one, that 2D array. Okay, by doing that, what happened? You know. You change the reference. This guy used to point to that to the array. But when you do this, it changed the reference point from that array to the array that reside inside the polynomial function object right here. So any further change, this calculation is not done on that array, but it is done on this array. Okay, so basically because the array here has changed because of all this calculation, that will also change. You're not going to have the original polynomial function anymore because the internal value of the original polynomial function will be this, the same as the definite integral arrays. Okay, so to fix this, you cannot just return the array inside the polynomial function, but you need to return a copy of it. Okay, you need to return a copy of it, and that is not going to be needed. Okay, but you can save it, but it's not going to be needed anymore. All right, so let's modify this a little bit. I just want to make sure I save this. It could be a pain in the neck. Okay, so let's kill this guy out and just do double poly. Okay, and that in here, instead of return just poly, you are going to return, well, double new poly equals new double 11 and 2, and then make a guess. I equals 0, I less than poly dot length I plus plus. You are going to clone it. Okay, so new poly I0 is poly I0, and new poly I1 is going to be poly IN1. And when that is done, you just return new poly. Okay. And now let's try it one more time. Compile this one first, followed by compiling that one, and try again. So when we di dot write estimate, right, from 0 to 4 with 5 intervals, and now things is more like it. 28.96. 28.96. Okay, so you just hit that, right? This error is tricky, and if you're not aware, you could spend all night just figuring out what happened. Okay, you have all that you need to have to finish this project. So try to work this out at home. You're going to need this on Tuesday. Okay, so any question? The rest should be easy now. You only have what left estimate and the midpoint estimate. Okay, and then just make the correction to this. Okay, because this is not going to work. Just correct them to reflect the actual parameters for each of the methods that you have. Questions? Good. I'll see you on Tuesday. Thank you very much.